Assalamualaikum warahmatullahi wabarakatuh. First of all, thank you Sir Maman for giving us opportunity to do this lab project. So for this lab project, we have been assigned to do the sensitivity of analysis of elastic properties in determining fluid type. So for this lab project, I, Muhamad Nabbil Bin Ali, along with Muhammad Syahme Farhan bin Muhammad Yazid and Muhammad Azmin bin Rayman have prepared this slide for you. So we will start with the presentation overview. So for the first part, we will start with the introduction. We will move to the literature review, methodology, discussion, and conclusion and reference. Thank you.
Thank you, Nabil, for the presentation overview. Hi and Assalamualaikum. My name is Mohd Azmin, and I will be explaining first about the introduction, whereby in this introduction we are going to talk about what we are doing in this project and also the objectives of our project. For the first part of introduction, for this project we are studying and elaborating the sensitivity of 4 elastic property domains. And for the objectives, the first objective is for us to study the sensitivity of the domains of elastic properties in determining various fluid types. And the second objective for us is to determine and choose the best attribute that can give maximum outcome with the corresponding fluid type characterization. Moving on to the second agenda of this project, which is the literature review. For this literature review, we will be reviewing several articles that is related to our project. For the first part of the literature review, I will be explaining about our first 2 domains of elastic property, which is Poisson's ratio and also P impedance and S impedance. For the first point of Poisson's ratio, Sun Wei and Chan 2016 has quoted that it has good application in fluid identification, especially in gas characterization. And for the second point for Poisson's ratio, the same author, together with Jain and Jabakar, 2012, has quoted that the fluid identification for Poisson's ratio is most effective in identifying gas due to gas saturated rock, which is we known as gas sand, produce the lowest Poisson's ratio, which is as low as 0.3. And for P impedance, the reservoir characterization insufficient due to inability for it to distinguish the effects between lithology and also fluid content, according to Jung, Luluan, and Devagosh 2016. However, this problem can be solved by combining the P impedance and also S impedance together in the seismic data, which they can highlight the fluid content of that area.
Hi, my name is Muhammad Syahme Farhan bin Muhammad Yazid. Now, I will share about the article review of the lambda mu rho domain and SQP-SQS attribute. Lambda mu rho analysis can be done by separating the response of both of the lambda rho, which is the incompressibility, and the mu rho is the rigidity sections to gas sand versus shales, as demonstrated by Goodway in 1997 in identifying gas sand. This is also supported by Anderson in 2000, where he stated that many different lithologies can be identified by cross-plot of the lambda rho versus mu rho, as each lithology has different rock properties response subject to fluid content and mineral properties, including grain shape. SQP and SQS is a quite new attribute that were developed by Maman, Deva and Chow in 2016, where they mentioned that SQP has the highest coefficient correlation with gamma ray log. Meanwhile, SQS attribute has the highest coefficient correlation with water saturation and resistivity log. They further explain that SQP attribute is very useful for classification and seismic sequence to stratigraphic analysis. Now, we will continue with our third agenda, which is the methodology. As for the project, we will be comparing regarding the cross-plot and the inversion. Therefore, hereby are the procedures that are required in order to generate the cross-plot and inversion in the GeoView software. First, we need to launch the GeoView software and then select and rename the display of the well logs. Second, we need to perform the fluid replacement modeling for the selected depth interval. Third, we are required to key in the SQP and SQS equation in the GeoView software. And fourth, we need to generate the cross-plot and seismic inversion for the each attribute that we will be created, and compare for the best fluid type delineation from the result of the cross-plot or the seismic inversion.
So for the fourth agenda, we will talk about the result and discussion. In this slide, we will explain about the limitation, advantages and disadvantages of each method and decision making. So for the first limitation that we will face is we are only comparing result of cross-plot from one field in Sabah Basin only. Meanwhile, inversion result that we use from a field in Malay Basin. The second limitation that we face is we are unable to provide cross-plot and inversion results for S impedance. And the last but not least, the data result that we will use are taken from previous research, not through GeoView software application. So for the next slides, we will talk about the advantages and disadvantages of 4 elastic property domains, which is Poisson ratio, the second one P impedance and S impedance, lambda mu rho, and SQP and SQS attribute.
Moving on to the first advantage and disadvantages of our first domain, which is Poisson's ratio. Poisson's ratio is effective in fluid identification, especially in gas. Meanwhile, the bad side of it is only effective in identifying gas sand effectively, whereby it has the lowest Poisson's ratio. Meanwhile, for other lithofluid or other lithology, it may not be able to detect it clearly because it has a high Poisson's ratio value rather than the gas sand.
Next is the advantages and disadvantages of P impedance and S impedance. For the advantages of P impedance and SP impedance, P impedance can be directly computed and compared to well data. The second advantage is it can do a relation between porosity and acoustic impedance. For the disadvantages of P impedance and S impedance, it is not efficient enough to identify lithology and fluid content.
Now, we will be discussing about the lambda mu rho advantages and disadvantages. For the lambda mu rho, the advantages is it enables to separate the gas sand from the wet sand or shale, and also it shows the separation into the 4 zones of the gas, oil, brine and shale. The disadvantages of the lambda mu rho is it is not showing the optimum lithology and pore field separation.
For the fourth domain of our elastic properties, we have SQP and SQS attributes. For SQP and SQS attribute, they have their own advantages and also disadvantages. For the advantages, SQP enable to distinguish lithology differences and seismic sequence stratigraphy analysis. Meanwhile, for SQS, SQS enable to distinguish fluid type and delineate gas sand from wet sand. Meanwhile, for the disadvantages, SQP cannot determine fluid type precisely and unable to delineate gas sand from wet sand. And for SQS unable to identify hydrocarbon prospects precisely because SQS is depending on SQP to identify what are the perfect type of lithology to hold the hydrocarbon prospects. So, after considering the advantages and disadvantages of our elastic property domains, our group has decided to choose only one, which is the best elastic property domain for determining the fluid type, which is our choice would be SQP and SQS attribute. Why we choose SQP and SQS attribute? Because SQP resembles the gamma ray log, which efficient in lithology identification. Meanwhile, the SQS resembles the resistivity response, whereby it is efficient in delineating fluid types. The cross plots of SQP and SQS clearly plotted the lithological effect of shale and sand in the vertical axis. Meanwhile, on the horizontal axis, the fluid effect of wet and gas sand can be plotted. Now, let us compare the cross-plot results of the 4 elastic property domains. The first cross plot on the left represent VPVS against Poisson's ratio. Meanwhile, the cross plots on the right in figure 1 showing acoustic impedance versus VP over VS. This data is gained from an article which is quoted by Shirley, Almana, Hermana and Ghosh 2017, which is situated in Sabah Basin. For the first cross plot, which is VPVS against Poisson's ratio, we can see that the cross plot distribution is not distributed well enough, but it is distributed in a uniform way. But then, the lithology or lithofluid from this cross plot can be delineated quite well, which is it can be characterized into gas sand, oil sand, water sand, and also shell. This also applies to the second cross plot, which is acoustic impedance versus VPVS, whereby you can see the difference of lithology due to the well-distributed cross plot, which is gas sand, oil sand, water sand, and also shell. But we can see an overlapping of water sand and also an oil sand, which can bring some confusion towards interpretation.
Hereby are the comparison between two cross plot of lambda rho versus mu rho and SQP versus SQS cross plot. As we can see, both are able to discriminate the lithofluid of the gas sand, oil sand, water sand, and shale. Unfortunately, the lambda rho versus mu rho cross plot does not show the distinct separation between the silty sand and the shale, as silty sand and shale curve almost overlap with each other. But in SQP and SQS, the attribute clearly represent the four distribution curve of the gas sand, oil sand, water sand, and shale, where you can clearly identify the lithology and separate it better than the lambda rho versus mu rho. Hereby are the seismic inversion of the SQP and the SQS. So the figure displays the SQP volume as a lithology indicator, and the right figure displays the fluid indicator, which is the SQP volume. The combination of both attributes managed to delineate the reservoir package.
Moving on to the last part of our presentation is conclusion and references. So for the conclusion, we conclude that SQP, SQS are the more refined and sensitive in determining fluid type. The comparison shows that SQP, SQS attributes are the most suitable in delineating silty sand dominated formation as in Sabah Basin and Malay Basin. Hereby, this is our reference list of the article that we use throughout our entire project. So, I think that's all from us. Thank you for listening for our presentation. Please be reminded to stay at home and stay safe. Cheers.